problem. Here is the problem statement. The volumetric flow rate of HCl solution coming from the manufacturing process is 11.6 liter per hour, and the average concentration of the HCl, so that is 0.014 m or 0.14 gram mole per liter. Calculate the gram mole of HCl in 88 meter cube of the solution and determine the molar flow rate of HCl. So that we have to calculate. And then find the mass fraction of HCl of the solution. So now here the given data. So volumetric flow rate is given. So that is given. Then concentration, so 0.14 m or 0.14 gram mole per liter, that is given HCl concentration. Then volume of the calculation, that is we have to calculate the volume or we have to calculate whatever we have to calculate, that calculate gram mole of HCl in 88 meter cube of the solution. So that volume for calculation, that 88 meter cube, and then molar mass of HCl, so that we know that H is 1.008 gram per mole and Cl is 30, molecular weight 35.453. So molar mass of HCl is 36.46 gram per mole. And density of the dilute HCl solution, that is 1000 gram per mole, gram per liter. So that is the approximate as water due to the low concentration. So now next is that solution procedure. Now calculate the gram mole of HCl in 88 meter cube. So for that, convert the volume to liters and multiply it by the given concentration. And then next is calculate molar flow rate, multiply volumetric flow rate by concentration. And then calculate mass flow rate, convert molar flow rate flow to mass flow using the molar mass of HCl. And number 4 step is calculate mass fraction. Divide mass flow rate of HCl by the total solution mass flow rate. Now here first convert that volume from the meter cube to liter. So that we have to convert volume from meter cube to the liter. So volume is given 88 meter cube. So multiplied with 1000 liter per meter cube. So volume will be 88,000 liter. And then calculate the total gram mole using the concentration. So gram mole of HCl is nothing but volume into concentration. So volume we know that 88,000 liter and concentration 0.014 gram mole per liter. So we'll have, if I do the calculation, we'll get that gram mole of HCl is 12232 gram mole. After getting that, so that first answer, gram mole of HCl in 88 meter cube, so that is 1232 gram mole. So now next is calculation of molar flow rate. So use volumetric flow rate and concentration. So volumetric flow rate, that is given 11,600 liter per hour and concentration is given 0.014 gram mole per liter. So we can easily calculate molar flow rate, that is 164.4 gram mole per hour. And from that we can answer that molar flow rate of HCl is 162.4 gram mole per hour. Next we have to calculate that mass fraction. So calculate mass flow rate of the HCl. So mass flow rate is, so we know that molar flow rate, so 162.4 gram mole per hour into the molecular weight 36.46 gram per gram mole. So that will give, so 5921.1 gram per hour. And then the calculate the total solution of the mass flow rate. So total mass flow rate will be that volumetric flow rate into the density. So that will be 11,600 and then 000 gram per hour. And then calculate mass fraction. So mass fraction will be, so that 5921.1 gram per hour divided by that total mass flow. So that will be the mass fraction. So that will be 0.00051. So mass fraction will be that 5.1 into 10 to the power minus 4. So that is 0.051%. So that is that final result is, so first one that gram mole of HCl is 88 meter cube is 1232 gram mole. Molar flow rate of HCl, so that is 162.4 gram mole per hour. Mass fraction of HCl in the solution, that is 5.1 into 10 to the power minus 4, that is 0.051%. So that's it. Thank you.